Hello everyone, today I will be showing you how to create an autonomous car using Unreal Engine, reinforcement learning, and Unray. Unray is a tool we have been developing to create and train intelligent behaviors in simulation, deploy them in complex environments, and maintain full control over how agents learn and act. Unray is thought as a plugin, also a platform that you can use to create simulations for video games or simulations for robotics. We are working on an implementation to integrate Unray and Unreal with some platforms like Arduino, Raspberry, and some other hardware platforms, open source platforms. At the moment, we are using it to train simulations of different agents like drones, cars, and also for video games, some behaviors for NPCs. The core capabilities of Unray are you can create adaptive agent behavior, reinforcement learning infrastructure, modular intelligence architectures, and we are working on make simulation to real transform, language-based reasoning, and real-time inference. We have a panel in which you can create your experiments, run them, and analyze their performance with metrics and insights. You only have to define the environment, configure the agent, and train and deploy. In this tutorial, I will be covering all the steps to create the autonomous driving car, as you can see in this video, in the web page. First, you have to go to the download button. Well, I will let the link of this website in the description. You have to go to download and download Unray for Windows. It's the panel that you will be using to create experiments, and the Unreal plugin to connect to the simulation in Unreal Engine. You have to download the Unray panel here in download Unray for Windows exe. You download the exe and then install it. It's kind of an executable, but it saves its files in app data, so there's no complex process of installation. Then you have to download the Unray plugin. Unray plugin, it's visible in Fab Marketplace. I have already downloaded it, so I can view it in the launcher. If I go to the launcher, it is going to tell me that I have already installed it in all the compatible engines. You have to download it and install it in Unreal Engine 5.7. It's the current supported version. Going back to Unray panel, it is important to note that Unray relies heavily on Docker because it depends on many dependencies that will be very difficult to set up in the right way. So we decided to distribute it with Docker, but don't worry, it's very easy to make the process. The only thing you have to do is install Docker Desktop and then come back here. To install Docker Desktop, you only have to go to the web page of Docker and download the installable. Here you can download the installer for Docker Desktop for Windows and install Docker. Only thing you have to note is that Docker Desktop runs for a specific version of Windows, but you can find that in the documentation of Docker. It's especially important that your version of Windows have a Windows subsystem for Linux. It's found on Windows 10 64-bit, Enterprise Pro or Education, and Windows 11. After you install it, Docker Desktop, Unray panel will tell you that Docker it's not running, so you have to make sure to run Docker Desktop. And that's it. You don't have to do anything else with Docker. We press check again, and we are going to enter the Unray panel. First time we enter to Unray panel, we are going to find this login to create our account. It's easy. You have to just put an email and a password or continue with Google. I'm going to use this account, and that's it. I have logged in, and now Ray is going to tell me that the backend is not running because we have to install the containers. We press start now, and the backend start to download automatically using the services of Docker. It can take up to 10 minutes because the containers weighs about 10 gigabytes, so just be patient. Well, the download have finished and we are ready to start to create our experiments. After we finish setting up right panel, we are going to Epic Games Launcher and launch Unreal Engine 5.6.1. It's the current version supported by the plugin. Now let's create a game using the vehicle template from games. And that's it. After we started the project, you can try the vehicle template, make sure it works. And also we are going to know that this template doesn't have a wall, so the car can go outside of the circuit, so we are going to fix that. The easiest way to do that is by going to the content browser and look for the SM track. There we are going to find the segment of the track, and we are going to create a wall. Add a collision, a box simplified collision, and select the box collision. There it is, and make it a little bit tall, not so much white, and you can use Alt and click to duplicate the wall. That's it. Now if you go to the map and go to player collision, you're going to see that the map and the track has this wall surrounding the track. This is important because our car is going to be limited right there, and also using line traces we are going to measure and find a way to avoid the walls and keep the car inside the track. Now let's start configuring our project. First we have to activate the plugin. Going to plugins and activating Unray. It says it's beta, that's right, you have to restart the engine to do that. Now we are going to configure the vehicle to use Unray. We're going to use the vehicle template blueprints sports car, the BP vehicle ADB sports car. We need to put the vehicle right in the track because we need to configure it from here. For you to control the vehicle that you put instead of spawning another one, you need to select the vehicle and make it auto possess player by player 0. Now you can control the vehicle to test the walls and anything else. Now we are going to edit the blueprint. It is really important that you configure some default values from the blueprint. First, make sure you make it auto-processable by AI. Place it inward or spawned. That's very, very important. If you don't do that, the vehicle won't drive by itself when you use the Unray connector. Next, to use Unray, you need two things. First thing is the connector. We are going to use the values, well, the blueprints that are inside the plugin. You have to make sure that you have plugin content activated in this option. Then going to engine, plugins, Unray content, blueprints, and you have to choose connector MA. Just drag it to the scene and put it somewhere in there. That's right. Second thing you need is the agent that you are going to control using the connector. In this case, our agent is the car. To make the car available for the plugin to control it, you have to implement the BI agent interface. You do that going to class settings, implemented interfaces, add, and looking for BI agent. Compile it, and that's it. Now we're going to start to configure all the options to control the vehicle. Let's start in order. First RL, then a step. In a step, you have to put whatever you want to do the agent to do when you take a step in your RL cycle. So we are going to create two variables, side and forward, to receive the values of the step. The agent receives the steps or actions, you might call it actions, through this method called step. It can receive it like box actions that are it's an array of floats, multi-discrete actions that is an array of integers, a discrete action that is only one integer, and multi-binary actions that is an array of binary values. Most of the cases you will be using box actions. That's the case in this tutorial. So let's get the two values that we are going to receive from our panel. We are going to make the second value the side and the first the forward value. The side is going to be set directly, and the forward it's going to use a simple rule. If the value is greater or equal to 0, it is going to be set in the value, and otherwise it will brake the car. It will apply the brakes of the car. To apply the brakes of the car, we are going to drag the vehicle movement component and get the set brake input node. To brake the car, we use 1, and to lose the brakes, we use 0. We need to multiply by -1 because Ray and all the backend that uses Unray gives values in the range of -1 to 1. So if the value is -1, I mean less than 0, we need to multiply it by -1 in order to make the breaks to go from 0 to 1. And also, let's apply the brake lights to make sure the brakes are being applied. Now, something you need to take into account is that usually you will drive this car using a control or using the keyboard. But given the fact that you are going to manage or drive this car using an event, you need to create another event to drive the car using these values of side and front, forward, side and forward, and you need to call that event from the tick to apply these values that are being fed from the RLA train cycle. So let's do that event. We select the vehicle movement component and use the set throttle input. That is the node that it's responsible of applying the throttle of the car. One for throttle and the second one is for steering. In throttle we use forward value and in steering the side value. Next we need to put this event in the custom inputs, in the tick, sorry. Also, if you want to try your inputs, you can use the enhanced input actions that are available in the template. First one is AI throttle, and the second one is AI steering. And that's right. The second function you need to set up is reset. In reset, you need to consider that if your agent is an agent that uses physics, it's very advisable that you use the create actor method. If your actor doesn't use physics, you might opt to not use it. And this is because setting just the position of the actor, especially if the actor uses physics, can cause troubles because the actor will teletransport the physics, and the first step it's going to be biased to the previous step of the training. Also, it can make very noisy cool starts. So again, if your agent uses physics, as it might be most of the cases, I advise you to use the create actor method that I'm going to use here. First, you need to use the spawn actor, and you are going to spawn an actor from this very same class, the vehicle ADB. ADP sports car. To spawn transform, you need an spawn transform location. I do recommend you to create a variable for the location and the rotation. Oh, sorry. And make these values editable from the instance. Take into account that these values are going to be passed to the child that is going to be created. Make sure you use always spawn, ignore collisions, and then call the reset return node and pass the new agent as the new actor and take the create actor box. Compile, and that's it. Next event is the isDone function. We are not going to use the truncated, but it's always available. You can truncate the episodes given some number, some value, yeah, you can use the truncated method, but we are going to use just the isDone. Regarding the isDone method, we are going to create a variable called hit, and this variable is going to be checked when the car hits a wall. To do that, we're going to create a box surrounding the car. And make it big enough to surround the whole car. Now we come back to event graph, to the event graph. And look for the component begin overlap of this box. Here we are going to set the hit value when the box touches the walls. And that's it. That's the only condition we use to reset our car. Now we need to set up the getReward function. But first, I'm going to show you how to get this value. First, we get the vehicle movement component, and from here we need to get the getForward speed value, like this. We print this value, and realize that the values goes from 0 to 3000 or more. And if you go backwards, it's something similar. And that's not useful for our purposes because as we are using RLlib, we need to clamp these values from -1 to 1. So first we need to divide this value by 2000. Doing this, the values are going to be centered in 0 and reduced by order of magnitude. And the max values are going to be or about 1.2, 1.4, etc. And that's pretty much useful for our purposes. Then we need to make sure that our car is always going forward and not staying just stationary. So we're going to discount a value of 20 to make sure that our car always receive a penalty for being static. And oh sorry, a value of 0 dot 02, 0.02 to make sure our car always receive a penalty if it stays stationary. So we are enforcing it to always move forward. Now that I have shown you this value, this is the value that we are going to use as a reward. Minus 0.02 if the car stays static or not fast enough, and a value of 1 or more if the car moves forward. I think we even need to make the car go a little faster, so make this value 0.1, and yes, that's better. This way we make sure our car is not going to be static. You can change this value as you make fit, but we are going to use it just like this, and that's it. Next step is setting up the get observations method. Also, as in actions, in get observations, we can return box observations, multi-discrete observations, discrete observation, or multi-binary observations. In most of the cases, you're going to use box observations, and that's the case in this tutorial. Here, it's very, very, very important that you create a variable from box observations, because we need to know beforehand how many observations we are going to use, and we are going to find later why that is important. Next, we need to trace the position of the car in the world and trace the obstacles. To do that, I'm going to make a function that should traces to cast the walls in the track. We create a scene where in the place we want the traces to start. In this case, I'm going to start them from the front part of the car. Now we need to get these values, the values that are returned from these traces. So we need to get our total observations, and it's very important to, by default, set the 7 spaces for these observations. Now for each trace we set up the value corresponding to that trace. We take the index from the for loop, the distance from the out hit. When you get the distance from the hit, it's important that you make a condition, because when the trace doesn't hit anything, the value is going to be 0, which is wrong because the value should be the total distance, meaning that the line trace is clean, or you don't have anything front of the line trace. So let's do a select here, and if the value is false, it means if the trace didn't hit anything, we are going to give the same value as the total distance. Let's do this a variable. And assign it here, in the case that the trace didn't hit anything. If the trace did hit anything, we're going to return the distance at which said hit occurred. And then, as I mentioned before, it is very important that we normalize these values, so we are going to divide this value between the trace length, because that's the highest possible value, and mathematically it will make the larger distance a 1 and the minimum distance a 0. Then we need another observation to make the algorithm understand that we are measuring the speed of the car. So we are going to get the vehicle movement component again, get the forward speed, and we are going to get something similar to this value, with the exception that we are not going to subtract anything. And we are going to add another field here, and it's important that you from the very beginning create the elements by default, because this can lead to errors, unexpected errors with Unray. So let's set array element. We're going to make this one the 8th index, because the first 7 from 0 to 7 are used by the line traces. We assign the value and put it here. Something very important you need to note here is that I am setting the observation in the event tick, but that it's not always the case, and that's because the get observations method it's called at the same pace of get action, well, of the step method, the reset method, and the other methods that are in the interface. That is very, very important because Unray by default will tick 30 times per second, and the engine might be ticking at maybe 90, 100, 120 frames per second. And if you are measuring a value that it's affected by the speed of the engine or by any other kind of situation that might accumulate the observation in every tick, the value it's going to be biased, or the value is going to be wrong, because the measure, the observation is taken exactly 30 times per second. In this case, it doesn't matter because the get forward speed is a pure function. I'm going to always get the value, the speed value at that second, at that tick, and it is not going to be affected by this situation. Same happens with the traces. The traces distances are not going to change if I measure 1 or 3 times per frame, but if you have some value that maybe accumulates or get the observation with a function that change something in the level, take into account that this value, that this function of get observations, it's called only 30 times per second, unless you change this value. But if you don't, always take that into account. Now that you have already set up the get observation method, we need to set up the agent configuration in order to be seen by the plugin. So we go to get agent config, and we are going to do the next thing. Given that the plugin gets the values from this variable, we need to promote this to a variable. This is very important. And then configure these values. By default, this is called the default policy. You can change it to any name. I recommend you to use car/policy and keep the policy name with an append of policy. The agent name could be just car. The observation space and the action space remains the same as box, and the actions shape are 2 because we have 1 or 2 spaces in our box actions array. So we need to put 2 here. The actions bounds remains the same because we use it -1 and 1 as our normalized values. The observations shape here are the ones that we set up in this array total observations that we are returning here, and the total observations are 8 in this case. But as I mentioned before, we have an error here because the array is not 8 but 9, so we need to add another place here. And it is important because here in the space shape we need to put that 9 to make the plugin able to detect the amount of spaces we are going to return in our array of observations. Also, the bounds are -1 or 1 because we are normalizing the values. You can use any other values here, but I strongly recommend you to use -1 and 1 because errorlib uses this as a default. maybe you can bias the model or change some internal parameters that might be confusing at this point. So just keep with -1 and 1. Finally, I recommend you to go to construction script and set the spawn transform location and rotation from the initial values to make sure every time the card respawns in the reset method, it respawns always in the same place. If you don't do this, the card is going to be spawned always in 0, and that's going to make the car appear maybe at the center of the track or the level, I don't know, but that is going to be annoying for sure. At this point, we can do this. Going to go to window, open Unray, and scan agents. You're going to find you have car agent, action 2, box 2 dimension, observation box dimensions 9, and policy, car policy. Here in our connector, we need to set up the actors list. That's actually pretty easy. The only thing you have to do is create an array element and choose your car. We're going to set up the max episode steps in maybe 4000, steps per sample in 1000, and we are going to latch the action. Latch action, it's meant to keep the button press, because as I mentioned, the action is going to be made like 3 times per second, and if you don't latch the actions, if your car or your agent depends on continuous actions, it's going to be quite of buggy, because it's not going to execute the action or the button or the trigger in every tick, but in every step. If you need the action to be latched between steps, you can just select this, and the action is going to be maintained between one step through the other. And that's it. Something important here is, at the moment, we need to create, if you have maybe 2 agents, you need to set them up like this. You create 2 actors, and then you have to select them every time, because the connector is still using a configuration of 1 per agent. We are working on make it easier in a way that you need to use 1 and just create an actors list. But at the moment, this is the default configuration. It is important that you set the runner ID for the first one as 1 and for the second one as 2. This way, the plugin is going to recognize that you have 2 agents and will manage them independently. We scanned the agents, and we found that we now have 2 cars. In these configurations, the cars are going to be trained in parallel, not in a multi-agent fashion. So that's very important to note. If you do this, it's very important that each car ignore the others, because if you don't ignore each other car, they are going to collide and make the exercise, the experiment, get wrong results. So we go to the box here and set the collision presets as custom, and we are going to ignore the vehicle collision responses. Next, we are going to create experiment in the Unray panel. Here you select new experiment. At the moment we are just using cloud. The experiment is going to be saved in our cloud, but you can use local. Local is still under development, but I promise you we will fix some errors and you are going to be able to also storage your experiments in your computer. But at the moment, just use cloud and continue with the tutorial. Cars tutorial. Description, autonomous driving car. We're going to use PPO, single agent, and select an image. Then we press next. It might take some time. Great. We give a name to the training hyperparams, maybe hyperparameters test 1. Let's just stay with the default values: string batch size 1000, 10 epochs, learning rate, gamma, VF loss coefficient. You can set all those values. We are going to be integrating some other hyperparameters in the upcoming updates. Press next. Here the plugin is getting our cars. We have 2 cars, 2 observations. 9 observations, 10 actions, and that's it. If the agents aren't properly loaded, we can press get from emp and we will get the list of agents updated. We press save and finish, and that's it. Next, we need to select here in our panel. As we can see, we have all the values of Unray, metrics, lineages, checkpoints, but we don't have any at the moment. Here in config, it is very important that you create a new execution to make sure that you can train your experiment. Here we have our training config, the IP address, port. You at the moment just leave it like that. No emperors. We have to put 2 because we have 2 agents and each agent in Unray is an embrunner, so put 2 emrunners. You can leave the rest of the values the same. We create a new execution and that's it. We go to overview, select our execution, and from here we can start the training session. Something I forgot to mention is that you are going to have an annoying error if you don't make sure that the car is not colliding with itself when it restarts. So in order to avoid that error, or in case you are having that error, you need to go to the vehicle and the event graph, and you can put a print to make sure the collision is not detecting other cars or itself. Also, you need to go to the mesh. The mesh is going to have by default the vehicle setup. You need to make it custom, and in custom you need to set up the collision response for vehicle to ignore. You have to do that for chassis main and the wheels and also the glass. You go to collision presets, set set them as custom, set the object type as vehicle, make sure it's vehicle because by default it is forward dynamic, and set it up the collision responses for vehicle as ignore. When you finally have this as ignore, the final result should be that when you start the car should trespass the other cars and should not print the collision in any case. Also, you need to set the box that you put before as vehicle and also in collision responses for vehicle to ignore. That's also important. Then, when the car bumps against walls, it will print the collision, but not with anything else. Finally, we can go again to our panel and start live. Now, as you can see, the cars will start training and will start the process of learning how to avoid the walls. We can follow the process right here. Oh, okay. Maybe you might have this problem that when you unfocus the Unreal Engine window, the engine stops. You just have to go to editor preferences. You need to go to you have to search for background and look for the option of use less CPU when in background. You tick this, and now the engine will continue to run even when you unfocus the window. Now you can go to metrics and see the metrics of the training. Just wait for it to be ready. Now here they are. We have the average reward. We can also have the max reward, new reward, and all the necessary graphics to follow our training. And that might be all for this tutorial. Some final notes that are important to share with you. First, that this example is just to show you how to create the experiment. We didn't look for the best result or policy. For this, you can try using longer traces and iterating over the reward, because here we use it very simple reward. Maybe you can try some other formulas or other kind of formulas to achieve better results. To improve training speed, use as many agents as you can. The max amount is your number of CPUs minus 2. That's a limit imposed by ERLib. For example, my computer has 8 cores, 16 logical CPUs, so I can make 14 agents to run in parallel. At the moment, that's a limitation we have in Unray, but we are working to improve that limitation. And finally, as I mentioned in the point 1, to improve generalization, use a track with curves to the right and left. This example converged easily and very fast because the car just have to turn to the right. If you make a track that goes right and left, the car is going to generalize a better policy to go both ways. So that's an important part. We didn't cover it here because it is going to be in the next tutorials or future experiments in which we are going to show you how to make we are going to show you how to make curriculum learning and other techniques that allow you to improve the result of the policy. Finally, to finish the experiment, you can go to the panel and press stop live. Pressing this, the experiment is going to finish. You can go to checkpoints and see the results. Go to metrics and see the average reward and any other value you may be interested on knowing about your experiment. The lineage is a feature we are working on to make a kind of repository of experiments. In a way you can iterate over experiments, and that's it. When you need to close the panel, just close and press stop and close. And that will stop the containers in the background. That's important because you're not going to run out of resources in your computer, because the containers that runs the training are going to be stopped when you close the panel. As you can see here, they are all stopped. And yeah, that's it for this tutorial. Thank you for watching, and don't forget to join our Discord and sharing us your doubts, your requests, or any improvement you think we need to do. Thank you, and see you later.